Yeah, you should know what nuclei they come from, and what nuclei they may go to. Okay, this is over cranial nerves. Are there going to be questions over where they originate, where they innervate? So you should have an idea about where they go. My hesitation on its origin and insertion is because most of it is the muscles, not so much the nerves. Yeah. Just wanted to make sure I knew what you were. Know everything. Yeah, that's good. Pretty much it. Yeah, typically with cranial nerves, you want to know the name, you want to know the number, what nuclei are involved, what they do, where they go, what they run with. Okay, today we are going to do the accessory nerve and the hypo nerve. So those are our final two cranial nerves. The quiz should open up after the lecture, and it will be open until Sunday. There are going to be a couple questions from week, I think 3 and 4, actually, to be honest. Okay, so cranial nerve 11, that's X1 or XI. That's the accessory. I'm a little old school, I still call it accessory. You probably probably are more used to it being referred to as spinal accessory. Not a lot of slides here. But that doesn't mean there's not a lot of material on the slides, because there is.
Wait, which one was this? Was this number 11? Which PowerPoint was this? Number 11?
11, yeah.
Thank you.
Yeah, it'll say XI. Okay, with the accessory nerve, you know, you're sort of at the transition point where we talk about classically we did this with it, but you know, the current times we do this with it. Accessory is one of those areas. Classically, we would talk about a spinal component and a cranial component. Okay, the spinal component is much more well known than the cranial component, and that's why you hear more about the spinal accessory. And I don't know if, you know, with your mnemonic, if you use accessory or spinal accessory, it would change your mnemonic considerably. But cranial nerve 11 has classically, air quotes. Actually, let me, I think I need to open this up for the online people. See, online people, you should be here. You're missing all the good stuff. Oh, there is nobody online. And yet there were about 20 more people who signed in. Oh, there we go. Okay, so there's a spinal component. The spinal component originates from spinal cord. That's why it's called spinal component. From about C1 to C5, give or take a C. Right, might be C1 to C4. Right. So those fibers are going to come out of the spinal cord. They're going to come together in a trunk that ascends up next to the spinal cord. That's what you see right there. Okay, this starts outside of the skull. It starts outside of the skull, but it goes into the skull. It gets into the skull. It gets into the skull through the foramen magnum. Okay, from C1 to C4, there is a motor nucleus called the accessory nucleus. And that's where these fibers originate from. They ascend up, they go through the foramen magnum, now they are inside the skull. Cranial component, okay? Cranial component, there will be a couple of little roots that come out of medulla. Okay, medulla is a cranial part. Couple of roots come out of medulla. Their origin is the nucleus ambiguous. Nucleus ambiguous. Okay. So now we've got both parts of the accessory nerve within the skull. Those two parts, those two trunks, come together and share a connective tissue sheath. So they run together, they look like one nerve. They exit the skull through the jugular foramen. exit the skull through jugular foramen. Once outside the skull, they separate again. The cranial component will go to pharyngeal and laryngeal muscles. The spinal component goes to sternocleidomastoid and trapezius muscles. Okay, on our picture, here's your sternocleidomastoid, here's your trapezius. Okay, the functional component for our accessory nerve is considered to be special visceral efferent. And that's based a little bit on the embryology. You know, when you look through the cranial nerves in general, you can justify almost all the functional components. Accessory gets a little hard. It almost seems like, because of the type of muscle the spinal component goes to, it almost seems like it should be, you know, you can argue special because it's neck region. Somatic efferent, but we don't have that classification, so, oh well. Okay, now within the skull, it looks like one nerve. That's why classically it was considered one nerve. Okay. And I know they still ask questions like, which cranial nerve has a spinal component and a cranial component? They being other people than me in high stakes exams. So you still have to know this. Now, the modern day view, straight out of Gray's Anatomy, this is what Meredith says. This cranial component is actually part of the vagus, a little rogue part of vagus. And that makes sense because it starts at the same nucleus ambiguous. It goes to similar muscles, pharyngeal and laryngeal muscles. And that's what you will typically see now, is that that's just a rogue part of vagus. You know, even when they're running together, within that connective tissue sheath inside the skull, even when they're running together, they're not exchanging fibers. So they actually kind of stay separate the entire time. And so that's an easy argument to make, that it's just part of the vagus that just happened to be running with the accessory, the spinal part. So, modern view, it's spinal accessory, the cranial part would be vagus. Classically, you've got a spinal component and a cranial component. And again, you know, you want to trend toward modern day, what we think now, but you occasionally see some of these old-timey questions that haunt you from years past. So you have to be aware of that story too. Here's a little summary diagram. This is from Patistis and Gardner. Here is our accessory nucleus. It runs from around about C1 to C4, C5-ish. Little roots come out. They come together to form a trunk that ascends up. Next, the spinal cord enters the cranium through the foramen magnum. And here, they're just going with vagus nerve. This is your nucleus ambiguous. Fibers run together. They exit together through the jugular foramen, and then they split again. That cranial bit, vagus, goes to pharyngeal and laryngeal muscles. The spinal component, sternocleidomastoid and trapezius. Questions? Okay, now we're going to 12, CNX2. That is the hypoglossal nerve. Okay. At the medulla, that's this bottom bit, medulla. You've got a bundle of fibers. These are motor fibers. This is called the pyramid. Then you've got a little bump called the olive. The olive will contain a nucleus where fibers go to the cerebellum. And olive. Posterior to the olive, you will have cranial nerve 9, 10, cranial part of 11. Right? They are coming out of the little sulcus, and this is more just kind of general information. A little sulcus called the post-olivary sulcus. Okay, because it's posterior to the olive. If you go in front of the olive, anterior to the olive, there is another sulcus called the pre-olivary sulcus. Pre-olivary sulcus. And you see these little roots coming out. There's several of them. Those little roots will form the hypoglossal nerve. Hypoglossal nerve. So 12 is anterior to the olive, pre-olivary. 9, 10, part of 11, post. Another way to describe this is that the hypoglossal nerve fibers exit between the pyramid and the olive. The nucleus of origin is easy. It's hypoglossal nucleus. And it works like motor nuclei in the spinal cord. In fact, functional components the same: general, somatic, efferent, GSE. Right? It works like a lower motor neuron. I know you might not know that yet, but you will. Okay. Exits the cranium through the hypoglossal foramen or canal. Okay. Do you remember your terminology from osteology? I think it would have been like week 1. Remember what a foramen was? What's a foramen?
The hole.
It's a hole. Okay. What's a canal?
A divot.
Divot.
A divot for a vein that's built around a vein or a nerve.
Built around a vein. Yeah. Yeah, that's one way to look at it. You know, there's different really definitions for it, but basically, the way I look at it is it's a hole with depth. It has an opening, starting point, and an ending point, where the hole is just a hole. Okay. Problem here is, what is depth? So you're going to have a lot of authors write that the hypoglossal nerve runs through the hypoglossal foramen. It's just a hole. Others say, no, there's like a micron worth of depth there, so it's a canal. Whatever, I don't care. Okay, hypoglossal foramen, hypoglossal canal. You'll see both. It's not really enough to argue over, but if you need a paper written, write your argument. So, leaves the skull through the hypoglossal foramen/canal, swings upward and innervates all of the muscles of the tongue, intrinsic and extrinsic, with one exception. The one exception is palatoglossus. Palatoglossus. Okay, the palatoglossus will be innervated by the vagus nerve. Palatoglossus innervated by vagus. Anytime you see a muscle, except for the palatoglossus, with glossus in the name, okay, you've got hyoglossus, styloglossus, right? If glossus is in the name, it's going to the tongue. And it's innervated by hypoglossus. Okay. Here is our summary diagram. Here's our hypoglossal nucleus. Notice it's actually, typically we want to think of motor things being ventral, but hypoglossal nucleus ends up being somewhat dorsal. Fibers extend down, exit between pyramid and olive, exit the cranium through hypoglossal canal or foramen, goes to all the muscles of the tongue, except which one? Yeah, palatoglossus. And what innervates palatoglossus? Vagus. Yay. Okay. Now, your typical somatic motor system, I'm going to keep this really simple. Your typical somatic motor system has upper motor neuron, lower motor neuron, muscle. Okay? So lower motor neuron goes from spinal cord to muscle. Okay? In our autonomic system, you go from spinal cord to brainstem to ganglion to muscle. So there's a two-step process for autonomics. One step for general somatic stuff. All right? So lower motor neuron to muscle. Okay. Upper motor neurons. We're going to have two sources for hypoglossal. One's going to be voluntary, one's going to be involuntary. Okay, voluntary movement of the tongue originates in the motor cortex, the area for head and neck, motor cortex, lateral side, right above lateral fissure. Okay, so that's where this starts. And that's for voluntary movement of the tongue. So like, I meant to do that. That was no accident. Right? So me sticking my tongue out at you, voluntary. There's another area though called the reticular formation, and you will hopefully learn about it next quarter. That's an area that developed last week, early on during the development of animals. But it's one of the earliest parts of the nervous system to develop, which means it's sort of geared toward survival. And so in this case, it's going to be involved with eating and speaking. So for involuntary movements of the tongue, that starts at that reticular formation. Okay, those fibers will go to our hypoglossal nucleus, synapse, and then the lower motor neurons That's for involuntary movement of the tongue. Examples of involuntary movement of the tongue is motion and close foot while you're chewing. And you're not thinking about that typically unless you bite your tongue. Or the movement it makes when it's pushing the food back to your throat. Typically, again, you don't really think about that as it's happening. I mean, even speaking, I'm thinking, humans talk, but, other animals, to us it might be noise, but they do have different kinds of noise stuff in it. They can click, depending on the animal, they can click their tongue, or different kinds of barks. But the way they move their tongue in those cases, it might be a little voluntary, but a lot of that movement while you're speaking is involuntary. I mean, I'm not really thinking about having my tongue make a certain position in order to get my words out. I might be thinking about the words I want to come out, but not really thinking about the tongue during it. So those involuntary movements start at the reticular formation, they go to the hypoglossal nucleus, and then to the tongue muscles. Voluntary starts at the cortex, goes to the hypoglossal nucleus, to the tongue muscles. Okay. Questions? Okay. I'm just starting your test. It doesn't really matter when you start it. Or your quiz, your knowledge test. So it should be open. I'm going to start working. But that is all the stuff for this week. Any questions on any